Today we will explore the concept of zero and what it will lead us in the future. So don't forget to like, comment, and of course subscribe. Let's start.
Okay, let's start with what seems like a really simple question. What is zero? I mean, most of us, if we actually pause for a second, we probably just say it's nothing.
Right.
An absence, maybe that placeholder on your bank statement when everything's perfectly settled. But what if we told you that this nothing is just the absence of something, but actually the most powerful, the most complex, maybe the most inevitable concept in the entire galaxy? Would you even believe us?
It sounds like pretty wild hyperbole, I know. But this is one deep dive where the underlying math is actually maybe even more precise than the metaphor sounds. Zero isn't just a symbol for an empty column, you know? It's the structural cornerstone of modern algebra. It's the origin point for all geometry. And looking forward, it might even be the primary fuel source for future engineering, and maybe surprisingly, the necessary language of human aesthetics, too. It's like this fundamental hinge, a point upon which any advanced civilization, say type I or beyond, absolutely must turn.
Wow. Okay, so our mission today is pretty ambitious then, especially for those of you tuning in who really love exploring that intersection, that nexus between pure mathematics and, well, deep culture. We're essentially trying to move zero from being this sort of forgotten mathematical footnote to placing it right at the very definition of what advanced intelligence is. We're going to explore why basically every civilization, whether we're talking hypothetical deep space aliens or, 17th century Europeans, why they were all sort of compelled to invent it, and how artists use its absence, its nothingness, to generate this really overwhelming emotional presence. And then maybe the wildest part, how future engineers are apparently already planning, like now, to turn the void itself into basically cost-free energy.
Yeah, the scope is huge. We've synthesized, well, an enormous stack of sources for this deep dive. Our material covers everything from pure set theory, like the actual mathematical definition of the number zero itself, to a pretty detailed 5,000-year flash history of its discovery and acceptance. We've also got philosophical texts on cultural aesthetics, especially looking east and west. And then, yeah, the really cutting edge stuff, speculative theoretical physics that actually treats zero as a kind of material resource. We're calling that final section the cosmology of zero. It gets pretty mind-bending.
Okay, well, let's unpack this.
So let's start with a really strong foundational idea, a thesis, if you like. Zero is not just some human cultural quirk. It's not like deciding to use base 10 for counting or, the invention of money, which could have happened differently. No, zero is what we call a convergent intellectual artifact.
Convergent intellectual artifact.
Yeah.
Okay, what does that actually mean in practice?
It means that just like, say, the wheel or the lever or even understanding gravity, any intelligence anywhere that reaches a certain cognitive level.
Yeah.
The moment it starts to calculate or engineer things or communicate complex ideas, it will be forced to discover zero. It's like the universe's structure demands it.
Ah, okay. So it's not really a choice. It's more like a structural pressure that's inherent in calculating reality itself. And looking at the sources you mentioned, they detail like 5 specific, pretty much non-negotiable pressures that basically guarantee any advanced culture will stumble upon zero. Let's maybe walk through those because they seem to cover a huge range, everything from basic shopping to abstract math.
Exactly. We can start with the most grounded one, the most perhaps relatable one, accounting pressure. Think about it. The second an economy moves beyond simple, immediate, face-to-face barter, I'll give you 3 fish for those 2 axes right now. The moment you introduce concepts like debt or planning for the future or keeping ledgers, you inevitably run into the situation of I owe you nothing. The balance is settled.
Right, the zero balance.
Precisely. And once a society invents negative numbers, which you need to track debts, deficits, loans properly, zero just appears automatically. It becomes the neutral balance point. It's that essential boundary between having a surplus and being in deficit. Without zero, your ledger can only really track 2 separate columns, stuff I have and stuff I owe. But it can never compute that final netted total. And that total is absolutely crucial for any kind of scalable trade or complex economy.
Okay, that makes perfect sense for commerce. But the second pressure you mentioned, place value pressure, that feels like what really unlocks scale for us humans, isn't it?
Yeah.
That's why we can write a number like, say, a trillion without needing a completely new symbol just for trillion.
That's exactly right. Positional notation, where the position of a digit determines its value, is basically the only way to write really big numbers without needing an infinite alphabet of symbols. 1 symbol for 10, 1 for 100, 1 for 1,000. It just doesn't scale. Whether you choose base 2 like computers, or base 10 like us, or even base 60 like the ancient Sumerians used, positional notation is just non-negotiable for large-scale stuff, engineering, administration, science. But here's the catch. For that system to actually work, you absolutely must have a marker, a symbol that explicitly says this specific power of the base, tens, hundreds, whatever, is absent right here.
Can you give us that concrete example again? What happens if we try to write numbers without a zero symbol?
Okay, imagine you only have symbols for, say, 2 and 5. In a world totally without zero, how do you tell the difference between the number 25 and the number 205 or 250?
You can't, can you? They'd all just look like 2-5.
Precisely. They all collapse into the exact same string of symbols, a 2 followed by a 5. 0 acts as that absolutely critical punctuation mark. It's what shifts the meaning of the 2 and the 5 depending on where they sit. It holds the door open, so to speak, for the next position, making sure the 2 and 205 means 200s, not 210s. Without 0, any kind of complex computation just hits a hard wall. You couldn't do large-scale tax collection. You couldn't calculate orbital trajectories. It's the engine of mathematical scalability.
Okay, and the math only seems to get more abstract from here, but
Yeah.
maybe also more elegant. The third pressure is about symmetry.
Mm-hmm.
How does a concept like mathematical balance force a specific number like 0 into existence?
Right, this is the algebraic pressure. So if an intelligent species starts studying things like symmetry or motion or operations that can be reversed, which mathematicians lump together under the term group structure, they will invariably have to figure out what the identity element is. Think about symmetry. You perform an operation like rotating a square 90 degrees. To get back to where you started, you need the reverse operation, rotating it minus 90 degrees.
Okay, so 0 represents the idea of doing nothing, like no change at all.
Exactly. In any kind of group structure, the equation x plus a must have a unique solution. We're looking for that special element, x, that when you combine it with any other element, a, it leaves it completely unchanged. For addition, that identity element is, well, it's our 0. And this idea isn't just limited to simple numbers. It applies to matrix algebra, rotations in space, reflections, any fundamental study of structure and transformation. Basically, if you study how things move or balance or transform and return, you are automatically forced to invent an identity concept that behaves exactly like 0.
That's quite profound. Now, the fourth pressure, geometric pressure, seems to bring it back down to earth a bit, or at least to mapping things. It's about coordinates, right? Whether you draw them on paper or track them in space.
Precisely. Anytime you try to map a space, whether you're drawing coordinate axes like latitude and longitude on a map, or maybe plotting magnetic field lines around a star, you absolutely require an origin point, a starting point. You need a reference that says, effectively, this is here, not left, not right, not up, not down.
Yeah.
You have to define that point of, let's call it intellectual neutrality before you can measure any displacement from it. That central reference point is just geometrically necessary. And yeah, we label it 0, 0 on a standard graph.
Okay, makes sense. And the final one, the fifth pressure, information theoretic pressure. You call this the cosmic filter, the sort of ultimate barrier to entry for spacefaring civilizations.
Yeah, you could kind of think of it that way. This is really the bedrock of our entire digital age, and likely any digital age. Think about the simplest, most robust ways to send information without it getting corrupted, especially over vast distances like interstellar space. You need error correcting codes, and the most fundamental error correction, the most compact data compression. They all rely on the simplest possible distinction you can make, a 2-symbol alphabet.
On versus off, yes versus no.
Exactly. Charge versus no charge. Path taken versus path not taken. Yin versus yang, if you like. We call them 1 and no. So the implication is, if a species can build a radio telescope powerful enough to send a clear signal across light years, or a computer complex enough to process that signal, or even just an accurate abacus for complex calculations, they have already fundamentally discovered the structure of 0.
Wow, so it's basically baked into the fabric of communication and computation itself.
Precisely. If you can communicate complex information reliably, or build any kind of on-off machine, you've already discovered the necessary binary logic, and therefore the structural existence of 0 is implicit. Could a culture somehow avoid 0 forever? Well, only if they stayed completely prenumerate, never counting beyond 1 too many, never building even simple on-off switches, never generalizing concepts of symmetry or balance. Such a species would never develop radio or rocketry or radar. They'd be stuck. Zero, in a sense, finds you once you reach a certain level of complexity. It's not really the other way around.
Let's try and make that convergence idea more concrete. The sources you mentioned had some really cool kind of non-human discovery path scenarios. I love the one about the cephalopod merchants and their debt beads.
Ah, yes, that's a great illustration of the place value pressure in action. Imagine these hypothetical deep sea squid merchants, right? They tie knots in seaweed vines to count their pearls or whatever they trade. Now, they keep track of bigger numbers, tens. Hundreds, they need positional order. So they start leaving a no-knot gap in the bind to signify an empty position. Initially, maybe that gap is just emptiness, but over time, they'd realize the gap itself is a critical placeholder. It has to be there for the number to make sense. So maybe they invent a small marker like a shell fragment or a polished pebble to put in the gap just to guarantee the spacing is right. Once you have that sequence knot, marker for nothing, not, they've essentially treated the absence as a thing that has a value, even if that value is zero. Boom, they have zero.
That's brilliant. Well, what about the astronomical pressure? The calendar void example. An alien civilization relies on a binary star system for their calendar.
Right, imagine they live on a planet orbiting two stars. And their whole yearly cycle, their agriculture, everything depends on the regular pattern of these stars. But maybe every, say, 17 orbits, one of the stars disappears behind a huge, stable dust cloud for a whole year. Their primary celestial clock just vanishes.
So they have a gap in their timekeeping.
Exactly. They're forced to track a position in their calendar, a slot in time, that contains no visible astronomical event. They have to invent some kind of symbol, a glyph, that basically means count this time slot, but skip the usual star event. That glyph is zero. It's this necessary acknowledgement that the chronological order, the sequence, has to be maintained, even when the data you usually rely on is absent.
And physics itself can just hand zero over, right? This ties back to that information theoretic pressure, perhaps.
Absolutely. Any civilization that gets good at understanding wave dynamics, maybe they build sensitive instruments like Mach-Zehnder interferometers, tools that measure how waves interfere, maybe using single photons or electrons. Well, they will inevitably observe dark fringes. These are places where two waves perfectly cancel each other out. Complete destructive interference. The mathematical amplitude for that perfect cancellation, that point of absolute physical silence where the waves annihilate each other, is exactly zero. You don't even need complex math to label that initially. It's a direct physical observation of perfect absence. Nature hands you zero on a plate, forcing you to create a mathematical label for it.
And even something as fundamental as mapping orbits, like Kepler's laws, forces the issue too.
Yeah, through geometry and calculus, if you want to predict orbits accurately or figure out when eclipses will happen, you often need to use calculus. Specifically, you might integrate the area swept out by a planet as it orbits. That involves calculating something like the integral of rho theta from a starting angle to an ending angle. That lower bound, that starting angle, the point where you say, start measuring the area from here, that's the origin. It's the 0 point of the angle. Theta equals 0. So if you can calculate orbital mechanics with any precision, you've implicitly used 0 as the starting line for your calculations. The conclusion seems pretty inescapable, really. 0 is just fundamental to physics, to economics, to information theory, to geometry. It's everywhere structure exists.
Okay, that was a really powerful case for 0 being this, like, necessary mathematical citizen, an inevitable discovery. But now let's shift perspective a bit. If math demands 0, how does human culture, especially, say, aesthetic culture, art, design, how does it choose to use it? Because culturally, it feels like it's never just a simple lack of something, is it? It's more like what you call the perceptible absence. It's that moment where the artist kind of invites the viewer or the reader to step in and participate in creating the meaning.
That's a fascinating transition because we move from this realm of rigid necessity, math needs 0, to the realm of profound choice. The mathematician defines the structure of the void, you could say, but it's the artist who makes that void feel intensely well alive. And we see this articulated perhaps most powerfully in certain Eastern philosophical and aesthetic traditions where 0 or emptiness isn't feared but actually revered.
Let's start with a concept maybe some listeners have heard of, especially if they're interested in Japanese culture or design the idea of ma, the gap or the interval. How is ma different from just plain silence or empty space?
That's a great question. Ma isn't really silence in the sense of nothing happening. It's more like the sound of time passing made perceptible. It's the conscious, deliberate, almost visceral interval between things. In a lot of Western culture, there's this tendency to fill every moment, every space. Ma is the deep realization that the interval itself holds the most potential energy, the most meaning sometimes. Think of a traditional Japanese no drama performance. The actor might deliver a powerful line and then just freeze mid-stage. That powerful ringing silence after his last syllable, that's Ma. It's the deliberate, measured moment where the audience has to process the sound that just was and anticipate the sound that will be. The tension is in the gap.
So it's actively designed into the experience by the artist. It's not just an accidental pause or leftover space.
Absolutely. And it's used spatially, too. Think of the art of Japanese flower arranging, ikebana. You might have a dense cluster of flowers, but then one single stem leans sharply away from the group, out into open space. That lone stem gets its visual power, its force, precisely because of the emptiness around it. The space isn't neutral or negative, it's activated. The viewer's eye fills it, recognizing the shape that isn't there and how it defines the shape that is.
And that idea seems to lead pretty naturally to another Japanese concept, yohakunubi, which translates roughly as the beauty of leftover blank space. This is something Zen ink painters mastered centuries ago, right?
Yes, the mastery of white space, or unpainted space. In, say, 12th century Zen brushwork, you'll see these incredible landscapes where the painter deliberately leaves huge areas unpainted. Whole mountain ranges, the surface of a lake, distant horizons, they're just left as the white silk or paper. And that blankness isn't laziness, far from it. It reads as mist or sky or water, or sometimes just pure, unmanifested potential. The blank space often becomes the most detailed, the most evocative part of the painting, paradoxically. The artist denies you the explicit detail, forcing your eye, your imagination to fill in the distance, the weather, the sheer scale of it. The absence provides all the context and scale.
And underlying these aesthetic ideas, there's a deeper philosophical root too, isn't there? The concept of mu, the Buddhist idea of emptiness.
Right. Mu often gets translated simply as nothing, but that's a bit too simplistic, maybe misleading. It's more like notness or unness. It's profoundly different from literal non-existence. It points towards the absence of a fixed, inherent self or identity in things. Think of the Enso, that Zen circle often painted in one single, continuous, mindful breath. The empty space inside the circle, that's often pointed to as representing Mu. It's that space where thought hasn't yet stuck a label, where concepts haven't solidified. It's seen as fertile emptiness, full of potential, waiting to be engaged by consciousness. This is really where zero, or the void, shifts from being just a lack of something into a profound philosophical resource.
And you can see this powerful use of, vacuum, even in traditional literature. Haiku poetry comes to mind immediately. That classic 575 syllable structure often uses a cut, the kirigi, to deliberately open up an internal vacuum, doesn't it? Like Bosch's famous poem about the old pond, you get the frog jumping in, the splash, then silence. That ripple of absence that follows is almost the main event.
Absolutely. The white page around the poem becomes part of the poem itself. It represents the continuing resonance, the aftermath of the sound. Often, the entire power of a haiku resides in that single unspoken image or feeling created by the southern stop, the kirigi, and the silence that follows. The extreme brevity is key. It ensures that the silence isn't just an ending, but a continuing echo in the reader's mind. You even see related ideas in ancient Chinese feng shui, the art of placement. Empty space wasn't just background noise, it was considered the highway for qi, for life energy to flow. A painting showing a mountain cliff ending abruptly against untouched silk wasn't just depicting rock. It was meant to be ambiguous, solid rock and drifting clouds simultaneously. That ambiguity engages the viewer, pulls their breath, makes the depicted space feel larger, more alive. It's like an ancient interior design cheat gun using zero.
Okay, now let's jump across the globe and maybe forward in time a bit to the West. Because Western modern artists also use zero, or emptiness, but often with a completely different energy, right? Sometimes it felt almost weaponized. Aggressive, even.
That's a good way to put it. Western modernism, especially in the wake of the trauma of World War I, often used white space or extreme emptiness as a kind of hammer, a tool to smash centuries of representational art tradition. They were often seeking a kind of purity or an endpoint. Look at someone like Kazimir Malevich, his painting White on White from 1918. It's just a slightly warm white square, tilted slightly, floated on a cooler white background. It's basically zero contrast, visually, but conceptually. Maximum impact. It was intended as a radical statement, perhaps the absolute endpoint of pictorial representation. Art becoming pure concept, pure presence, challenging the viewer. Find meaning in this absolute reduction, if you can.
That must have been utterly shocking at the time, but still feels pretty radical today.
Oh, it was revolutionary. Then you have someone like Piet Mondrian doing something related but with strict geometry. His famous compositions, the black grids with blocks of primary colors. The untouched white sections in those paintings are just as important as the colored rectangles. They're treated as equally weighted geometric shapes in the composition. It's like silence being given a measurable structure, defined boundary.
And then you had artists who didn't just represent the void, they literally attacked the canvas to reveal it, like Lucio Fontana.
Exactly. Fontana, with his Concerto Spaziale, his spatial concepts, often called the cut series, took it a step further. He'd take a monochrome canvas, often a vibrant color, and make a single decisive slash, or sometimes several slashes, right through it with a knife. What he's doing is revealing the literal void, the physical space behind the picture plane. He turns emptiness from a representation into a literal physical place you could almost reach into. This wasn't just subtracting detail, it was aggressively adding the dimension of the void itself into the artwork, making absence tangible.
And this focus on absence, light, and space even became a formal movement, didn't it? The Zero movement, founded in Germany in the late 50s.
That's right, founded in Dusseldorf in 1958 by artists like Heinz Mack and Otto Pinet. They explicitly rejected the emotional turmoil of abstract expressionism that was dominant then. They wanted a new beginning, a 0 hour for art. They used materials like fire, smoke, nails casting shadows, reflective metals, and often just pure white pigment. The goal was to make light, movement, and physical space the actual subject of the art, rather than the artist's emotion. Think of someone like Jan Schoenhoven, part of the related Dutch Knoll group. His reliefs are these grids made of white papier-mâché cubes or ridges. The artwork isn't really the static object, it's the play of light and shadow across its surface, shadows that changed constantly throughout the day with the sun's movement. The shadow, the absence of light, is the dynamic part of the art. Or you look at contemporary echoes, like the Korean artist Lee Yu-fan. He might paint one single broad stroke of gray pigment on a large canvas, and then stop, maybe for a month. He calls the untouched canvas yohaku, that resonant blank space. He famously said, "The silence is louder than the note."
And we see this playing with the physical perception of zero in big installation art too. James Turrell's sky spaces are literally just a hole in the ceiling, aren't they?
Often, yes. A very precisely engineered rectangular or sometimes oval opening in a ceiling inside a specially designed room. It frames a section of the pure sky above. And the effect is astonishing. Because of the controlled lighting inside the room and the sharp edges of the aperture, the sky doesn't look like sky anymore. It looks like a solid, flat plane of luminous color. Apparently, guards at these installations often have to stop visitors from trying to wipe the dust off the painting because the framed zero space, the sky, looks so incredibly solid, so tangible, it tricks your perception.
Wow. And then there's Anish Kapoor's work with ultra-black materials.
Right, like his piece, Descent into Limbo. It looks like just a dark circle painted on the floor in the middle of a room, but it's actually a physical hole coated in Vantablack or a similar pigment that absorbs almost all visible light, like 99.96%. When you stare into it, your brain gets almost no depth cues back. No light reflects. It receives a signal that basically says, there is nothing here, zero light, zero depth. People report feeling dizzy, losing their sense of balance momentarily because it's such a powerful confrontation with a sensory void. It's using zero to physically manipulate perception.
So it seems like the common thread here, whether we're talking ancient Zen painting or contemporary installation art, East or West, there's this kind of underlying formula, maybe something like perceptible absence, mental presence.
That's a really elegant way to put it, yeah. The artist provides the structure, the frame, the vacuum. But it's the spectator, the viewer, the listener who provides everything else. You provide the memory, the association, the breath, the heartbeat, the flicker of imagination that fills that void. And in doing so, you make the emptiness feel profoundly alive, uniquely resonant for yourself. The zero become mirror.
Okay, here's where it gets really interesting, I think. Or maybe even more interesting. We really need to establish why zero is this quiet, almost invisible hero of mathematics before we can leap into how it apparently breaks physics later on. Because without zero underpinning the math, none of those advanced concepts we just talked about, from Turrell's sky spaces to Mondrian's grids, let alone accounting or computing, could even be structurally conceived or written down, right?
Absolutely. Zero provides the essential intellectual scaffolding for, well, pretty much everything complex. We can really pin down its power by looking at 4 absolutely essential mathematical functions it performs. Let's call them the 4 pillars of modern math built on zero. We already covered the first one pretty well. Its role as the placeholder in chief. That crucial function that makes our whole positional numbering system work, telling 502 apart from 52.
Right. So let's focus on the next pillar then.
Right.
The additive identity. This
Yeah.
is that rule that just says a plus 0 equals a. Now, honestly, that seems utterly trivial, like something a first grader gets instantly. Why is this seemingly simple rule so incredibly foundational for advanced math?
It looks trivial, but it's the tiny, elegant linchpin that holds up vast swaths of abstract mathematics. That simple rule, a plus 0 equals a, is what ensures the very possibility of all higher-level algebraic structures. We're talking about groups, rings, fields, vector spaces, matrix algebra, basically the entire toolkit mathematicians and physicists use to describe fundamental reality. From quantum particle interactions to the rotation of a satellite, the math relies on these structures. And every single one of those structures requires an identity element, something that can be combined, like added, without changing the other element. Without that 0, that identity element for addition, those structures simply cannot be defined. The whole edifice of abstract math basically collapses without it. It's that fundamental.
Wow. Okay. Pillar number 3. 0 serves as the necessary boundary between worlds. The intellectual demilitarized zone, you called it earlier.
Exactly. It provides that natural, unambiguous origin point. Think about the number line stretching infinitely in both positive and negative directions. 0 is the dead center. Think about the Cartesian plane, the xi graph. Everything is measured relative to the origin point, 0, 0. Think about temperature scales like Kelvin or Celsius. 0 provides that crucial reference point. Before 0 is properly understood, how did you measure cold? You kind of had to count up from the freezing point of water, which is arbitrary. With 0 and negative numbers, you can define temperature relative to absolute 0 in Kelvin or a fixed point, Celsius. It's the constant neutral reference that allows us to define direction, positive, negative, debit, credit, north, south, and magnitude relative to absolute neutrality.
And the 4th pillar, maybe the most dynamic one, it's the engine of the infinitesimal. This sounds like the heart of calculus and advanced physics.
It absolutely is. Calculus, which, let's face it, is the foundational mathematical language for all modern physics, architecture, economics, engineering, you name it. Calculus is literally the art of getting almost infinitely close, but never actually, dividing by 0. Concepts like limits, derivatives, rates of change, integrals, accumulation, they are all defined by operations where some change, like the change in x, which we write as x, approaches 0, gets infinitesimally small. Calculus is the mathematics of change, of motion, of flow, and you can only calculate continuous change precisely by measuring infinitely small differences that are heading towards 0, but never quite reaching it in the division step. 0 is the conceptual destination, the limit point that defines the entire journey of calculus. Without it, the whole system unravels.
To really appreciate just how fundamental 0 is, we need to look at its mathematical creation story. You mentioned set theory earlier, this incredibly elegant way mathematicians build every number in existence, starting literally with nothing.
Yeah.
This sounds completely mind-bending, but also kind of simple at its core.
It is. It's a beautiful example of mathematical self-sufficiency. It largely stems from work by mathematicians like Peano, Dedekind, and formalized using set theory, primarily by Zermelo and Frankel. You start with the simplest possible concept imaginable, the empty set, usually written as or. It's defined simply as a set that contains 0 elements. It's a container with absolutely nothing inside it. And then step 1 is just. We define the number 0 to be the empty set, so mathematically 0 equals a. 0 is the abstract concept of an empty container.
Okay, got it. 0 is literally an empty box. Now, how on earth do you use that empty box to build all the other numbers, like 1, 2, 3, and so on? That's where the successor function comes in.
Exactly. We define a simple operation called the successor function, usually written as SNN. The definition is SNMAN. In plain English, this means the next number, the successor of n, is defined as the set containing all the elements of the previous number, n, plus a new element, which is the set representing the previous number itself. It sounds complicated, but it's just a way of packaging the previous stage. It's how we count up step by step using only sets.
Okay, let's go really slowly here. Show us how you build the number 1 from 0 using only this empty set.
Right, so to get 1, we apply the successor function to 0.1 equals SS0. By definition, S0 E0 S. 0. Now remember that 0 is the empty set A, so substitute that in. S0 equals SAA. The union of the empty set with a set containing the empty set is just the set containing the empty set. So 1 it equals et A. The number 1, mathematically, is the set whose only element is the empty set.
Whoa, okay, hang on. So if 0 is the empty box, then 1 is the idea of the empty box, captured and put inside another box.
That's a fantastic way to visualize it, yes. The number 1 represents the first non-trivial concept generated from nothing, the concept of having the empty set. The existence of nothingness, quantified. Now let's build 2. We apply the successor function to 1.2 S1. By definition, S1 equates 1, 1. Now, substitute our definition of 1, which is S1. So the number 2 is the set containing 2 elements. The element that is the empty set, which represents 0, and the element that is the set containing the empty set, which represents 1. So 2 or 0, 1 if you use the number symbols, and you just keep going. 3S2, AA2. Every single natural number 1, 2, 3, up to infinity is just increasingly elaborate, nested packaging of that initial humble empty set. 0 is literally the seed from which the entire infinite set of natural numbers blossoms.
That is genuinely staggering. It's like the ultimate bootstrapping process. And from those basic counting numbers, the natural numbers, mathematicians then just add operations and concepts to fill in the gaps on the number line.
Right. Essentially, yes. Once you have the natural numbers built from 0, you introduce operations and their inverses. You need subtraction, so you define additive inverses, like 9n for every n that gives you the integers, stretching infinitely in both directions from 0. Then you need division, so you define multiplicative inverses, like 1n, for every non-zero integer that gives you the rational numbers, all the fractions. But even then, there are still gaps on the number line. Numbers like pi or the square root of 2 aren't fractions, they're irrational. So mathematicians developed sophisticated techniques like Dedekind cuts or Cauchy sequences to precisely define and fill in these remaining holes. That completion gives you the real numbers, the continuous number line we usually think of. And then, just for good measure, you ask, what about the square root of -1? You invent the imaginary unit and combine it with the reals that give you the complex numbers. And virtually every gigantic, complex mathematical structure we use today to model reality, from quantum mechanics to general relativity, is built upon these number systems, all ultimately traceable back to that single foundational concept, the empty set, 0.
That abstract power makes its actual historical journey, how humans discovered and accepted it, even more fascinating. It wasn't smooth sailing at all, was it? Let's ground this theory with that 5,000-year flash history you mentioned, because 0 had a tough time getting accepted.
Oh, absolutely. The very first hints we see are way back, around 3000 BCE, with the Sumerians in Mesopotamia. They used a base 60 system, and they developed a kind of proto-placeholder, often a slanted double wedge symbol, to indicate nothing in this position in their cuneiform tallies. But crucially, it was only punctuation. It signified an empty column. You couldn't do arithmetic with it. It didn't have the properties of a number itself.
Okay, so just a space saver, where did the conceptual breakthrough happen?
India.
Right.
Yes. The critical leap seems to have happened in India, probably somewhere between the 2nd century BCE and the 5th century CE. The evidence is debated, but manuscripts like the Bakhshali manuscript show clear use of a symbol for 0, often a dot or a small circle that was treated like a number. This shift from 0 being just a placeholder like the Sumerian wedge to 0 being an actual number you could calculate with, the Indian dot or shunya, that was arguably the single most important conceptual invention in the history of mathematics.
And who is the key figure who really codified its use, spelled out the rules?
That would be the Indian mathematician and astronomer Brahmagupta around 628 CE. In his major work, the Brahmasaphu Siddhanta, he didn't just use 0, he treated it as a full mathematical citizen. He explicitly spelled out the arithmetic rules we still use today. A plus 0 equals A, and an A 0 equals 0. He even tried to tackle the thorny issue of division by 0, though his rules for that, like saying 0, 0, 0, were incomplete and later refined. But he was the one who really integrated 0 into the formal system of arithmetic.
And the revolutionary knowledge then spread outwards, particularly through the Islamic Golden Age.
Precisely. Scholars in the burgeoning Islamic world, particularly in Baghdad's House of Wisdom, eagerly translated and synthesized knowledge from India, Greece, and Persia. A key figure was the Persian mathematician Muhammad ibn Musa al-Khwarizmi, working in the 8th and 9th centuries. He wrote influential books that introduced the Hindu numerals, 1 through 9, and the Indian concept of 0 to the Arabic-speaking world. His work on systematic calculation methods, al-Jabru al-Muqabala, gave us the word algorithm from his name, al-Khwarizmi, and algebra, from al-Jab, meaning restoration or completion. 0 was absolutely essential for the efficiency and generality of his methods.
But then, when these ideas, including 0, reached Europe, they weren't exactly welcomed with open arms initially, were they? Fibonacci introduced them around 1202.
No, there was immense resistance. Fibonacci, in his Liber Abaci, strongly advocated for the 9 Indian figures, plus the sign he called Zephyrim, from the Arabic sifr, meaning empty, which gives us both 0 and cipher. But European merchants, bankers, and even governments were deeply suspicious. They were used to the cumbersome but supposedly transparent Roman numerals I, V, X, L, C, D, M. Why the fear? Well, zero, this Zephram, seemed slippery, shifty even. It made calculations much faster, yes, but also more abstract, harder to check visually. There was a real fear it could be easily used to commit fraud, like changing 100 to 1,000 just by adding a circle, or that it represented a void, nothingness, which was philosophically and theologically troubling to the medieval European mindset. Florence, for example, actually banned the use of Arabic numerals, including zero, in official documents for a time in the 13th century, forcing merchants to stick with Roman numerals or write numbers out in full words. The power of nothing was genuinely terrifying to them.
Wow, I had no idea it was actually banned. But eventually utility won out, right?
Yeah, it was unstoppable. Despite the resistance, the sheer practical advantages for trade, science, and engineering were too great. By the 17th century, the cultural fear had largely subsided, replaced by widespread adoption and innovation. You have Descartes using zero as the essential origin, zero for his coordinate geometry, revolutionizing the connection between algebra and geometry. You have Newton and Leibniz independently inventing calculus, a system that, as we said, fundamentally relies on the concept of limits approaching zero. They were constantly dancing with the ghost of division by zero. And then finally, maybe the capstone. In the 19th and 20th centuries, set theory, as we discussed, formally established zero as the empty set as the absolute foundational seed of all mathematics. And almost simultaneously, Claude Shannon demonstrated that just two symbols, 0 and 1, were sufficient to build all of logic and computation, kicking off the digital revolution.
So yeah, zero started as just a humble punctuation mark in Sumeria and ended up as the indispensable cornerstone of the entire modern mathematical and digital world.
What a journey. Okay, so now we take another leap. Once we really internalize the idea that zero isn't just a mathematical abstraction, not just a cultural symbol for emptiness, a potentially an active, structural, material principle in the universe, then the rules of physics might start to look very different. This is where we move into the speculative domain we're calling the zero-verse, a theoretical realm where nothing structured absence might actually be structurally heavy, programmable, and maybe even a source of limitless energy. We're talking about theoretical consequences, potential discoveries that your listener's era hasn't yet uncovered, perhaps because the instruments aren't sensitive enough or the necessary mathematical frameworks haven't been fully developed.
Okay, deep breath here, because this is where we dive fully into the speculative physics. And I have to admit, some of these claims from the source material sound like pure out there science fiction. Let's start with maybe the most immediately absurd sounding one. The idea that nothing can have weight. A heavy, empty set. What does that even mean?
It sounds absurd, I grant you, because we're used to thinking about mass only in terms of baryonic matter, protons, neutrons, the stuff atoms are made of. But this concept comes from exploring the deep structure of mathematics itself, specifically the von Neumann hierarchy of sets we touched upon earlier. The theory posits that pure information, pure structure, has an equivalent mass energy associated with it, related to ideas like Landauer's principle, but taken much further. According to the calculations in these speculative sources, the empty set, our zero, once it's recursively packaged inside its own power, sets up to a very high theoretical level, denoted V omega plus 1 omega. The cumulative informational complexity, the sheer structuredness of that nested emptiness, has a theoretical mass energy equivalent calculated to be around 2.4 to $10 kilograms.
Wait, that number. That's more than the estimated mass of all the regular matter stars, galaxies in the entire observable universe. How can packaging nothing create actual usable energy or mass?
Right. It's crucial to understand this isn't physical matter appearing from nowhere. It's conceived as a measure of potential negative entropy stored in that pure mathematical structure. Think of it like this. Information has an energy cost to erase. That's Landauer's principle. This theory flips it, creating extremely complex, ordered absence might store potential energy. The idea is that a hypothetical future technology, an information drive, could tap into this vast reservoir of negative entropy. It would work by forcing the hypercomplex zero structure to partially collapse or simplify into a less complex, higher entropy state. And the energy difference released in that relaxation process could be harvested. You'd essentially be burning pure, structured emptiness for usable power.
Okay, my brain hurts slightly, but let's move on. If zero can be thought of as physically heavy in this informational sense, it must change how we view computation and mathematical singularities too. Let's talk about the idea that division by zero is clock. Traditionally in math class, zero is just undefined, an error, crash, game over.
It's an error, or undefined. only because we usually restrict ourselves to the standard real number line and its usual rules. In the zero-verse theoretical framework, the singularity you hit when you try to compute x0 doesn't just blow up into meaningless infinity. Instead, it's theorized to escape the light cone of the real line in a predictable way. The math for this involves something called chronometric compactification, essentially adding a time-like dimension or property to the concept of infinity.
So instead of just being an error message on a calculator, dividing by 0 becomes a measurable destination, like punching in coordinates.
Kind of, yeah. The result of hexy is conceived as landing on a specific point labeled in$50, which exists off the standard number line, but has a well-defined temporal vector or direction associated with it. This transforms division by 0 from being a mathematical failure into a potentially useful, precise computational step. The speculation in the sources is that this could be the mathematical key used in future faster-than-light FTL navigation systems. You'd literally be using the mathematical escape route provided by 0 to define and calculate shortcuts through space-time.
Okay, FTL travel via division by 0. Got it. The next point sounds wildly speculative again, and oddly biological. Zeros smell. You're saying the abstract concept of nothingness might have a distinct universal scent.
This one comes from sources looking at speculative convergence biology, trying to predict universal constraints on life based on physics and chemistry. The argument goes like this. For any carbon-based life form that evolves to store memory chemically, which might be common, they'll likely use complex organic molecules, maybe like terpenes in plants on Earth, to encode experiences and concepts. Now, such an organism would eventually need to represent the absence of a stimulus, or the concept of not present, or maybe even achieve true neural silence. They'd need a chemical marker for that null state. What molecule would evolution favor? The theory suggests it would converge on the simplest, lowest energy, most stable molecule capable of signifying null information within that specific biochemistry. Across thousands of simulated exoplanet biochemistries run in these models, the most consistently selected marker for 0 or absence turns out to be a specific class of molecule, a 0 ketone.
So, the characteristic scent of absolute nothing might be an olfactory constant across the galaxy for any life using similar chemistry.
That's the startling implication, yes. You could, theoretically, land on an alien world and smell whether the dominant life form had achieved the conceptual leap to 0 even before you tried to communicate with them. It would be a chemical convergence pressure running parallel to the 5 mathematical and physical pressures we discussed earlier, a biological inevitability linked to 0.
Mind blown. Okay, and finally, for the mind-bending facts section, a claim that links 0 right back to cosmology. Every 0 is a frozen black hole, or maybe inside-out one.
Yeah, this one is derived from pushing the implications of the holographic principle and the Bekenstein bound to their absolute limit. The Bekenstein bound sets a theoretical upper limit on the amount of information, measured in bits, that can be contained within a given region of space with a finite amount of energy. Now, what happens if you consider the energy E inside that sphere approaching absolute 0? As E goes to 0, the calculation based on the Bekenstein bound suggests the maximum number of bits that can be contained within that sphere collapses to exactly 1 bit. But it's not just any bit. It's the single bit representing absence, the ultimate off state. These sources term this theoretical 1-bit object a white fractal. It's like a singularity, maybe like a black hole, but one defined by 0 energy and minimal information. Perhaps like a black hole turned inside out, existing at the 0-point energy level. It's the most compressed, minimal unit of reality theoretically possible.
What could you potentially do with one of these theoretical white fractals, this 1-bit object?
Here's where it connects to cosmology. The theory suggests that if you could somehow isolate or create such a perfect 0 energy state, this white fractal, and then seed it, perhaps by introducing a single charged qubit, a quantum bit, it could potentially unfold or inflate into a new standard child universe governed by rules like Schwarzschild geometry, which describes black holes. The implication is staggering. Creating a stable new universe might, in this far future theoretical framework, be as simple as achieving and manipulating the absolute 0 energy state within a perfectly shielded vacuum chamber. 0 as the seed of everything again.
Okay, let's try to bring some of this astronomical speculation back down to, well, future Earth, their future engineering at least.
Yeah.
If we could truly master absence in these ways, what could we actually build? The first blueprint mentioned is zero friction propulsion. This sounds like it could rewrite space travel entirely.
It would completely demolish the tyranny of the rocket equation, that fundamental rule that says you need huge amounts of heavy propellant to accelerate anything in space. The concept here involves coating a spacecraft, or perhaps just a thin wafer attached to it, with a zero field resonator. This is a hypothetical device tuned precisely to the local absence potential of the quantum vacuum. What this resonator does, theoretically, is actively cancel out the zero-point field energy, the background quantum fizz or noise, inside the wafer itself.
Okay, so you create a patch of perfect quantum silence. Why does that make the spacecraft move?
It creates an imbalance. Normally, the quantum vacuum exerts a tiny, almost imperceptible pressure or friction on everything, but it's equal on all sides. But if you cancel the vacuum pressure inside the wafer, the external vacuum pressure now acts only on the outside surfaces of the spacecraft or the wafer system. This net pressure difference, pushing on the craft from the surrounding normal vacuum, generates a continuous, reactionless thrust. You're literally being pushed by the vacuum of space itself without expelling any mass. This leads to the idea of zero-sailing yacht spacecraft that could silently, continuously accelerate maybe by a few kilometers per second per month just by manipulating their zero field profile. The aesthetic of space travel would change completely. Ships might appear totally black, absorbing all light, seeming like holes in space, except maybe for relativistic star trails, because they're constantly managing a field of perfect non-information around them. Silent, effortless interplanetary travel.
That's incredible. Then there's zero entropy computing using something called the bit deletion engine. It sounds almost like applied thermodynamics designed by a minimalist Zen monk.
It's the ultimate dream of computational efficiency. We know from Landauer's principle, a fundamental concept in the physics of information, that erasing a single bit of information must, thermodynamically, release a tiny amount of heat into the environment. There's a minimum energy cost to forgetting. But this zero-verse theory proposes a loophole. If, before deleting the bit, you first zero encode it, which means mapping its state precisely onto the absolute ground state, the N0 energy level of the local zero field, then the energy required for the subsequent deletion step actually becomes negative. The process actively absorbs heat from the surroundings. The crystal lattice of the processor literally cools down slightly every time you perfectly erase a zero encoded bit.
Get out. So the data center doesn't just save on cooling costs, it actually becomes a net heat sink. It can heat the surrounding offices for free while doing calculations.
That's exactly the implication. Scale this up to a massive exaflop scale data center. Instead of needing, say, 50 megawatts just for air conditioning to stop it melting, it might actually output a net 6 megawatts of cooling effect. The cultural side effects would be immediate and kind of funny. You'd have slang like, "My laptop's running below absolute zero today." And yeah, system administrators and technicians would literally have to wear parkas and thermal gear to work inside the frigid server farms. Zero turns computation into a cooling process.
Okay, how about architecture? Zero mass architecture. Using emptiness as a building material.
This would completely redefine structural engineering, yes. The concept here is the zero block. Imagine a standard-sized block, maybe 1 cubic meter. Inside this block, future engineers use contained fields to maintain a stable internal zero horizon, a region where the effective mass energy is precisely canceled out or maintained at the absolute vacuum ground state. The result is a building block whose effective gravitational mass is practically nil. The source is estimated around 7 by centiarate kilograms. That's, well, 27 orders of magnitude lighter than the same volume of air.
So we're talking about building materials that basically don't interact with gravity at all. They just float.
Essentially, yes. They'd be almost perfectly buoyant in air or even in vacuum. You could build enormous structures, bridges, towers, entire city platforms that would just float at a desired altitude, perhaps held in place only by very minor magnetic tethers or stabilizers. Think about planning permissions. They wouldn't be based on square footage or tons of concrete anymore. They'd be granted based on the grams of residual gravitational interaction the structure is calculated to have. The whole aesthetic of a zero city would be utterly different. Weightless, transparent, seemingly defying gravity altogether.
Unbelievable. And finally, the ultimate energy solution. Zero-cost energy storage.
This builds on related concepts. The zero capacitor is a theoretical device designed to store energy not as charge on plates, but as negative vacuum energy. By manipulating the Casimir effect, the force between closely spaced plates in a vacuum, and carefully controlling the zero-point field within the device, it could theoretically store enormous amounts of energy in the form of a structured vacuum state below the normal ground level. The numbers in the sources are astronomical. A device just 1 liter in volume, operating within safe theoretical limits, could potentially store enough energy to run the entire present-day Earth for, well, assume it is 10 centuries, basically limitless energy storage.
That unimaginable amount of power from a liter-sized object. How does society even function when energy is that abundant and cheap?
The economic model completely inverts according to these speculations. Energy itself becomes essentially free. So, what do power companies sell? They might start selling silence leases. Because these zero capacitors, when discharging immense power, might have subtle side effects, maybe a slight cooling or a quantum field hum. So companies would guarantee quiet zones, exclusive rights to neighborhoods, where the discharge effects are guaranteed below a certain negligible threshold, say less than 0 decibels. Quietness becomes a luxury commodity. You might even see kids trading tiny zero marbles miniature, low capacity zero capacitors may be powerful enough to light a small city for a week. And their black market value wouldn't be in dollars, but maybe in rare digital poems or unique experiences, reinforcing that cultural value of absence and non-material worth.
And just to wrap up the cultural impact side, how does this zero-verse thinking affect the arts and media of the future? You mentioned zero-fidelity culture.
Yeah, right. This is the idea that media, music, films, books, games wouldn't be stored as massive data files anymore. Instead, they'd be encoded as a zero seed. A zero seed is conceived as the absolute shortest possible computer program or algorithm that, when run to 0 iterations, or maybe run in a specific null state environment, perfectly generates the entire creative work. The program itself doesn't contain the work. It contains the compressed implication of the work, the structure of the absence, which, when observed or run correctly, allows the viewer's consciousness to reconstruct the full experience. Distribution would just be the tiny zero seed, maybe only 256 bits of data, plus a unique, non-fungible zero-run license.
Ah, so if you try to pirate the seed, copy the program without the license, it just does nothing, or produces garbage.
Exactly. Piracy becomes definitionally impossible. Without the authorized license to run it to 0, the file either does nothing, produces a random noise, or maybe just elegantly collapses to an empty output state. It's like Yohaku no Bai, the beauty of blank space, applied directly to digital rights management. Revenue wouldn't come from selling copies, but from selling the authorized 0 runs permission to experience the work once or a set number of times. And critics, they wouldn't write reviews based on plot or character anymore. They'd carry handheld entropy meters. Their goal would be to find the interpretation or the run setting that produced the lowest entropy reading, meaning the work achieved maximum implication with minimum explicit information. The closer the work gets to vanishing entirely into pure implication, maximizing the viewer's required mental presence, the higher the critic's rating. The ultimate artistic achievement would be to create the zero cut, the version of a story or a piece of music that is so perfectly implied by its seed that it almost vanishes entirely, existing only in the resonance it creates in the licensed observer's mind. Hashtag tagged outro. So reflecting on this whole journey. 0 clearly began as something incredibly humble, just a punctuation mark, really, for nothing here in ancient Mesopotamian accounting. And yet, through millennia of development through India, the Islamic Golden Age, European resistance and eventual embrace, the rigor of set theory, and now these far future speculations, it seems to have evolved into the absolute theoretical and maybe even the future material basis for all post-singularity technology and thought. It really feels like the ultimate core convergence point, doesn't it? Where deep mathematics, sophisticated philosophy and aesthetics, and maybe even cosmic engineering all meet.
So what does this all mean if 0 holds this much potential power?
Well, perhaps it means the trajectory of an advanced civilization changes fundamentally. The culture that truly masters absence mathematically, aesthetically, physically, eventually stops digging mines for finite material resources. And instead, it starts digging holes in reality itself, metaphorically speaking, to extract effectively infinite negative entropy from the structured void. The very metric we use to classify civilizations might need an update. Forget type 1, 2, 3 based on energy consumption. Maybe the ultimate goal is to become a type 0 civilization, one that meets all its needs sustainably by taking out negative entropy loans directly from the 0 horizon, the vacuum ground state.
Wow, that leaves us with a genuinely provocative thought for you, our listener, to mull over. Based on these sources, perhaps the highest moral act in this theoretical zeroverse isn't about creation, but about elegant deletion. Becoming a zero saint, a conscious agent whose final ultimate act is to voluntarily and completely delete the record of its own existence, thereby gifting the universe an extra clock cycle of potential, maximizing the cosmic zero entropy balance, giving back to the void.
And maybe, for those of you who want to try a little taste of this, perform some amateur vacuum engineering right now, here's a practical exercise suggested in one of the philosophical texts. Find a quiet, dark room, sit comfortably, close your eyes, Count your heartbeats, maybe down from 10, 9, 8, all the way down to 0, and then keep counting into the negative, or just stay intensely focused on the silence after the count stopped. That interval, you're now experiencing the time after the conscious counting stops, but your awareness continues in the quiet. That feeling is a taste of the zero horizon. You are in that moment consciously guarding the vacuum.
A final thought then. Perhaps the universe began when nothing made a mistake about itself, when the hiccuped into existence. And maybe it will end only when that mistake is perfectly corrected, when everything returns to zero. Until then, maybe every silence, every pause between the stars, every empty space in our lives is actually a job opening. A cosmic classified ad. Wanted someone to guard the zero while it dreams.
Welcome back to the deep dive. We sift through the dense stuff so you get the core insights, especially for you future tech fans out there. Today we're tackling a really mind-bending question. What if friction? What if gravity? What if they were just optional settings? Not hard rules. We are going deep into something called zero-point propulsion. Think functional hoverboards, think vacuum drives, real potential tech here. And importantly, we're not talking rockets. We're not talking about big clunky electromagnets either. This is about manipulating the energy that's already in empty space, all around us, all the time. And maybe the wildest part, our source today suggests you can actually demonstrate the basic physics behind this. Well, stuff you might find for under $50.
That's really the core mission today, isn't it? To connect that high-level quantum physics with something tangible, something maybe heading towards real future technology. So we need to start with the basics. Two key ideas: zero-point energy, or ZPE, and the Casimir effect. Now, for you listening, ZPE is basically the energy left over in space, even when it's supposedly completely empty. Absolute zero temperature, nothing there, except this background hum. Quantum electrodynamics, QED, predicts it. And the Casimir effect, well, that's how we see that hum, or rather, how we can measure a force that comes from it when we manipulate space on a tiny scale.
So it's not about finding some new energy source hidden somewhere. It's about geometry, clever engineering of empty space.
Precisely. Yeah, geometry is a good way to put it. The engineers working on this actually call it engineered absence. They're not generating force like a jet engine does. They're creating these incredibly small gaps, usually under 200 nanometers wide. Think, like way thinner than a human hair. And in these gaps, some of those virtual particles, the quantum fluctuations that make up ZPE, well, they just don't fit. So the pressure from the quantum vacuum outside the gap pushes things around. That's what does the work. And our sources today, they give us both sides of this coin. We've got this amazing pilots log, the dream, the aspiration.
All right, the hoverboard prototypes.txt file.
Exactly. And then we have the flip side, these incredibly detailed DIY blueprints showing how you can prove the basic principle on your desk. Hands-on proof.
Okay, let's dive into that dream first. The pilot's log. This sounds like pure sci-fi, but it's presented as a real test log. Let's unpack that experience. It kicks off with just the raw feeling of it, the rise sensation. It's described as, well, not rising at all. The pilot says the world sinks away by just 2 millimeters. And the description is softer than breathing, which is quite poetic, isn't it?
It really is. It immediately tells you this isn't about brute force. It's subtle.
And the sound, or lack of it. No wheels clattering, no engine noise, just this faint 3 megahertz whistle. But it's not just heard. The log says it lives in the teeth. What's that about? Sounds intense.
That 3 megahertz frequency is absolutely key. That's the operating frequency. It's the rate at which the little resonator tiles on the board are vibrating to manipulate that Casimir gap. So you're not just hearing it through your ears. That vibration, that frequency, it's coupling potentially through bone conduction through your whole body. You're feeling the quantum field being actively messed with thousands of times a second.
Okay, so that vibration, that disturbance, that's the propulsion.
Essentially, yes. Because the pilot is very clear. The board doesn't accelerate with thrust. It's not pushing off anything. It says it removes friction from the universe right in front of the rider. Think about that. Removing friction.
The log notes 0 to 30 kilometers per hour in 1.8 heartbeats. That's quick. But it's not about horsepower, is it? It's described as force cancellation.
And that is the paradigm shift for you future tech fans listening. Conventional transport cars, planes, whatever, they fight inertia, they fight friction, they burn huge amounts of energy to overcome these forces. This board, it's sidestepping the problem. It's creating a pressure difference in the quantum vacuum itself to nullify the forces resisting motion. So the energy cost is just from modulating those tiny nano gaps, which is why, as we'll see, the power consumption is ridiculously low.
And the look of the thing, it
Yeah.
glows. A blue, it says. The color of nothing. Which apparently comes from a 100 nanometer vacuum pyramids fluorescing. What does that even mean?
Okay, so the e-blue is not just for show. Those vacuum pyramids are specific nanostructures etched onto the board's surface. They're designed to very precisely exclude virtual photons around a specific wavelength, 100 nanometers, which is deep in the ultraviolet range.
Huh.
When you restrict those quantum vacuum modes, you change the local electric field conditions right at the surface. This can cause residual energy to be released as light fluorescence. So you are literally seeing light generated by controlling the quantum vacuum. The board glows because you're actively managing this hole in space-time you're riding on.
Riding on a visible hole in space-time. Okay. Let's see how this friction dilution, as the pilot calls it, handles real-world physics challenges, like the stair-set drop, described as a terrifying 12-meter vertical drop onto concrete. Ouch!
Yeah, not something you'd normally attempt lightly.
But the log says the old way, just commit, leap, hope for the best that's gone. It's replaced by the physics of creating a 0.7 bar vacuum pillow and falling upwards. Falling upwards.
This is where you see the incredible control you get from that Casimir force. Remember, it's super sensitive to distance. That inverse fourth power relationship is key. Bob to 1-1 ever. To push away from the ground to create that pillow, the pilot just needs to make the nano gap slightly smaller. The log implies a change of maybe just 4 nanometers. Tiny. But because of that fourth power law, that minuscule change spikes the local pressure like crazy. Up to 1.3 bar, apparently. That's a huge repulsive force from almost no movement. It literally pushes the board away from the ground.
So it actively shoves the Earth away, enough to slow the fall to, 0.6 G, like slow motion?
Exactly, a controlled descent. But then how does it land softly from that?
Right, the landing. The log says as it nears the bottom, the gap expands, pressure drops sharply down to 0.3 bar, and the board actively sucks itself towards the ground.
It's managing kinetic energy by playing with the vacuum pressure, sucking itself down for a smooth touchdown. The log even mentions something incredible.
What's that?
It says the board surface cools by 0.3 degrees Celsius on landing.
Cools down.
The implication is that the impact energy, instead of becoming heat and sound like a normal landing, is somehow dissipated into the quantum field itself. It's like the vacuum absorbed the shock. No bang, just silence and a tiny temperature drop.
Wow, okay. Managing energy like that is one thing, but the maneuvers, the pipe loop, riding a half pipe loop.
Classic skateboarding challenge.
But here, it's not about speed. You don't need massive velocity to stick to the curve. It's done purely by pressure steering.
This really shows the fine control they have. To initiate that loop, the pilot actively changes the gap size across the board. It's not uniform. The log says 95 nanometers at the front, 105 nanometers at the back. Just a 10 nanometer difference.
10 nanometers, that's it.
That's it. But maintained precisely while moving, that tiny difference generates a calculated, wait for it, 4 kilonewtons of force differential between the nose and tail.
4 kilonewtons, that's a lot of force, like over 900 pounds from a 10 nanometer difference.
Exactly. It's enough to just wrench the board's trajectory around the curve almost instantly.
Hold on, maintaining a 10 nanometer difference across a board that's moving, presumably vibrating at millihertz, while the attractive Casimir force is trying to slam the plates together. That sounds like a monumental engineering challenge.
Oh, absolutely. That is the engineering challenge. You need incredibly fast, segmented piezo actuators. You need materials for those mirror plates that are unbelievably rigid, but can flex just those few nanometers perfectly, thousands of times a second. You have to actively fight that massive vacuum attraction, constantly adjusting. But the payoff is efficiency. The board itself is almost stationary relative to the little pocket of engineered vacuum it creates. The log says the rider's head never even points up at the sky during the loop. The sky rotates around the rider, who stays level inside their space-time hole.
Mind blown. Okay, from concrete and pipes
Ugh.
to water. The log calls water the ultimate challenge. Surface tension, dielectric constant, a Casimir engineer's worst nightmare.
Water is tricky. Its electrical properties are very different from air or solid ground.
So how does the board handle the city lake test?
It needs a system reboot, essentially. Switches to saltwater mode. This means dropping the frequency to 1 millihertz and actually widening the gap to 200 nanometers.
Okay, why the change? Wider gap, lower frequency.
It's tuning. You have to tune the resonator, the gap size, and frequency to the environment. Water's dielectric properties are different, so you need a different setup to efficiently exclude the relevant quantum vacuum modes. And specifically for salt water, they engage something called the plasmonic mirror effect. The log mentions silver and graphene layers embedded in the board surface. These materials interact strongly with light and electromagnetic fields, especially near conductive fluids like salt water.
So it's using advanced material science to adapt. Does it float then?
No, that's the key. It doesn't float. The log says it skis on vacuum alone. The contact patch with the water is essentially zero.
And the proof is in the wake.
Exactly. The wake isn't like a normal boat wake, it's described as a shadow. A region behind the board where the water waves are actually smaller amplitude is 3% lower.
Smaller waves? Why?
Because, and this is the kicker from the log, some 0-point energy got eaten. The board is literally consuming a tiny bit of the vacuum energy that drives wave formation to maintain its lift over the water, eating vacuum energy to cancel waves. Okay, one last maneuver. The wall ride 360, sticking to a vertical brick wall. That means switching from lift to stick. Pure reversal, yes. The pilot approaches the wall parallel, then instantly flips the phase of the piezo drive by 180 degrees. This flips the net force from repulsion to attraction, instantly. The pressure changes dramatically. The front drops to 0.2 bar, that strong vacuum exclusion, pulling it towards the wall, while the rear spikes to 1.8 bar maximum attractive force, clamping it on.
So it uses that massive pressure difference to just glue itself to the wall.
Like a suction cup made of space-time, as the log puts it. It's using the static Casimir attraction, the clamp force we'll look at in the DIY stuff later, to hold itself vertically. Then it uses subtle shifts in voltage to create torque and spin around.
Okay, the session ends. The stats are just nuts. 12.4 kilometers traveled, max altitude 4 meters, and the energy used, 0.11 kilowatt hours? That's
Yeah.
like running a light bulb for an hour.
It's incredibly low energy for that kind of performance. High speed, vertical maneuvers, water travel. But the final data point, the one that feels most significant, mass saved. 0.000 gram. The pilot's conclusion. Because the universe, not I, did the lifting. What does that zero reading really mean? It's profound. Think about it. If this was aerodynamic lift like an airplane wing, the mass saved would equal the lift force, right? Action reaction. If it was buoyancy like a boat, it'd be the mass of the water displaced. The fact that it's zero, proves this isn't counteracting gravity in the usual sense. The rider's mass is still fully interacting with Earth's gravity. What the board is doing is nullifying the other forces locally, the ground reaction force, air resistance, friction, by manipulating the vacuum pressure right underneath it. It's a localized warp, not a brute force lift against gravity itself. The universe is doing the tricky part.
And when you step off, when you leave that local warp, the log notes, the rider's legs feel heavier. Like Earth suddenly remembers you exist.
It's that sensory recalibration. You've been in this bubble where the normal forces are partly canceled. Stepping out, normal physics reasserts itself, and it feels heavy by comparison. And there's this final detail. The board emits faint clicks as it shuts down.
Yeah, each time a virtual photon pair is crushed into nothing.
That's likely the sound of the nanostructures, the resonator tiles, physically settling back to their resting state as the high-frequency modulation stops. The sound of the engineered absence collapsing.
And a scent of absence, ozone and pine.
That's probably trace gases or volatile organic compounds that were just present in the local environment, maybe pulled into the fluctuating low pressure zones near the board, being released as everything equalizes, the smell of the vacuum breathing out. So that whole incredible experience, riding the hole, the silent flight, the impossible maneuvers, it all hinges on real, measurable quantum physics. Things happen at the nanometer scale, driven at megahertz frequencies. But the amazing thing is, we can now shift from that high-tech vision to something much more accessible. How you, listening right now, could potentially demonstrate the fundamental principle making empty space do actual work with pretty basic stuff.
This is where it gets really exciting for the DIY tech fans, right? Bringing quantum effects to the workbench. The first project here is the Zero Lift demo, and the goal is pretty audacious. Show detectable, measurable lift from a homemade Casimir setup using a simple milligram balance.
Yeah, proving that you can make something effectively lighter using just vacuum modulation. The build described is, well, it's genius in its simplicity. Under $30, they reckon. You need a standard microscope glass slide, some mylar film, they say, from snack packaging, like a crisp packet, silver paint for conductivity and reflection, and the key component, a 40 kilohertz ultrasonic transducer.
Like the kind you find in old parking sensors for cars, or maybe a cheap ultrasonic rangefinder.
Exactly that kind of thing. You can salvage them easily. That transducer becomes the shaker.
Okay, so how does shaking mylar film make something lift? The mechanism.
Right, this is crucial. They set up a physical gap, maybe around 50 micrometers, between the mylar, coated with silver paint, and the glass slide, also coated. But then, the 40 kilohertz transducer vibrates one of the surfaces. That vibration isn't huge, but it modulates the gap distance by about plus or minus 25 nanometers, TM 25 nanometers. And that tiny movement is enough to push things into a really interesting regime.
The Lifshitz regime, is that what it's called?
That's right, sometimes called the retarded Casimir regime. Now, normally, for fixed plates close together, the Casimir force is attractive. It pulls them together. But when you vibrate the gap fast like this, something changes. Think about the force. It gets much stronger when the gap is tiny and much weaker when it's wider. Propto 1 and 4. Because the force drops off so fast when the gap widens, even though it increases when it narrows, the average force over one full vibration cycle isn't zero.
Wait, so because the pull is strong for a tiny fraction of the time, narrow gap, and the weak pull lasts longer, wider gap, the average isn't just the middle ground.
Essentially, yes. More technically, the time it takes for the virtual photons mediating the force to cross the gap, the retardation effect, becomes significant compared to the vibration period. This asymmetry means the time average force actually becomes repulsive, a net push outward.
A push from shaking the gap.
A push. And the result, the source says the glass slide demonstrably loses weight. You put it on a sensitive milligram balance, turn on the transducer, and the reading goes down.
Specifically, the notes say a drop of -4 milligrams, -4 milligrams. That's about 40 micronewtons of upward force.
It's tiny, but it's measurable. And it's direct proof. You're seeing the macroscopic effect of 0-point pressure pushing up because you're modulating that nano gap.
Yeah.
You've lowered the vacuum energy density underneath, and the normal vacuum pressure outside lifts it.
Okay, that's lift, repulsion. But the hoverboard pilot log talked about sticking to walls, about stability. That needs attraction, right? The clamp, absolutely. Lift is only half the equation. You need the attractive force too, the static Casimir attraction. And that's what the next DIY demo shows, the Casimir in a cup.
Show a 1 centimeter square metal flap clamping itself to a surface hard enough to lift 2.8 grams with no glue, no magnets, just vacuum.
Proving the raw sticking power of the quantum vacuum, the build is, again, surprisingly low-tech, a glass slide, a small brass shim, like thin hobbyist metal, and the key, tiny spacers. They use 200 nanometer spherical IO Euro powder.
Silica powder, where do you get that?
It's actually a common filler in some paints and coatings, so relatively accessible. These tiny spheres create a very precise 200 millimeter gap between the brass and the glass. They just seal the corners with a dab of epoxy.
So you've got two plates held exactly 200 millimeters apart. What happens?
Pure static Casimir attraction. Remember, the gap excludes the long wavelength virtual photons, but the full spectrum virtual photons outside the plates is still there, pushing inwards. This pressure difference slams the plates together.
And that $5 Propto 104 relationship is key again here, that inverse fourth power.
Crucial. Because the gap is so tiny, 200 millimeters, the force becomes significant, even over a small area. The theory predicts it should be enough to support about 2.8 grams for a 1 centimeter of laser area.
And the test proves it. The test is simple. Stick a tiny magnet to the top of the brass shim. Just as a handle, it plays no role in the force. Try to slide the shim down the vertical glass slide. It won't budge. It sticks. Held purely by vacuum pressure. Purely.
Oh.
And the final proof. Take a sharp toothpick, carefully pry up one corner of the brass shim just a tiny bit, let air in.
Exactly. Air rushes into the nano gap, equalizing the pressure, and pop. The force vanishes instantly. The shim slides right off. It proves unequivocally that the clamping force was the vacuum itself.
That's the same force the hoverboard pilot used for the wall ride, that magnetic traction feeling. Wow. Okay, those first two demos are amazing, getting nanometer precision with basic parts. But now we get into some really clever DIY fabrication techniques. First up, the thermal snap, using heat to create and seal the gap. Yeah, this one moves beyond just assembling parts. It's about using a chemical process to create a permanent sealed Casimir cavity. The goal is pretty ambitious for DIY. They lift over 3 grams, which is like 30 times the weight of the test coupon itself. And the tools needed: a high voltage pulse source and a standard kitchen oven, seriously.
Seriously. The fabrication relies on a carefully constructed bilayer material. You have a top layer of something stiff, like reduced graphene oxide, RGO, and underneath it, a sacrificial layer made of PMMA microbeads. PMMA is basically plexiglass plastic.
Okay, so a stiff layer on top of tiny plastic beads. What's the oven for?
Yeah.
Crucial step, flash baking.
Oh.
You put the structure in an oven at 250 degrees Celsius for about 6 minutes.
At that temperature, the PMMA beads don't melt, they outgas. They basically vaporize and escape through tiny pre-made microvents in the structure.
So the plastic disappears.
Completely, leaving the stiff top layer, the RGO, momentarily unsupported over the bottom substrate, which acts as the other mirror, and snap. Atmospheric pressure slams the top layer down onto the bottom. Because the surfaces are atomically clean after the big gout, they actually cold weld together around the edges, sealing a near perfect 100 nanometer vacuum cavity instantly.
You've baked yourself a sealed vacuum engine. Okay, how do you test it? How do you get lift?
You place the finished coupon on a sensitive digital scale, then you hit it with a brief electrical pulse. The source has 12 volts. This pulse runs through conductive traces built into the coupon.
And the result?
The scale reading jumps up. It registers a positive weight change of plus 0.35 grams for a second or two. The coupon pushes up against gravity.
Hold on, heating it makes it push up. That seems backwards. Wouldn't heating normally make things expand and maybe push down?
It is counterintuitive. Here's what's likely happening, based on the Lifshitz theory for these dynamic effects. Inside that sealed 100 millimeter cavity, you have a very strong attractive Casimir force pulling the top and bottom plates together. That's the default state. When the 12V pulse hits, it causes rapid, tiny thermal expansion of the material surrounding the gap. The container tries to get slightly bigger.
So the gap itself, the distance increases by a tiny fraction of a nanometer.
Exactly. And remember our friend 5-Popto-148, if del gets even infinitesimally larger, the attractive force drops off incredibly fast.
So the powerful pull holding it down suddenly weakens.
It weakens significantly. The scale, which was measuring the total downward force, gravity, plus the strong Casimir attraction, suddenly sees less downward force. Since the scale was zeroed with the attractive force present, this reduction in downward pull registers as a positive reading and apparent upward push or lift, so the explanation in the notes makes sense. Vacuum inside gets bigger so that nothing pushes up harder than the air outside. It's about reducing the internal attraction. Precisely. It's converting a tiny heat input into a measurable change in the quantum force balance. The measured lift, about 3.4 millinewtons, apparently matches the theoretical predictions for that kind of gap change pretty well too, within a factor of 2, which is great for DIY.
Visual proof of vacuum force control via heat. Amazing.
Wow.
Now, audible proof. The Casimir clip demo, making the quantum vacuum audible.
Yeah, this one is really cool. The goal is to create a detectable attractive force around 10 millinewtons, but then modulate it so that the force actually pulses at a frequency you can hear.
How on earth do you build something that sensitive?
It needs a mechanical amplifier. The design uses a tiny lever made from a piece of a razor blade. This lever is balanced very carefully on a piezoelectric disc, the kind you find in buzzers or musical greeting cards.
A razor blade lever.
Okay.
And the nano gap. How do you make that with kitchen chemistry?
This is my favorite hack in the sources. They create the spacer using clear nail polish.
Nail polish.
Yep. They dip a bent paperclip wire into the polish, let a thin film form, and then carefully transfer that ultra-thin skin of dried polish onto one surface. It creates a remarkably consistent gap somewhere between 70 and 120 nanometers.
Nanometer precision with nail polish and a paper clip.
Oh.
Incredible. So you have the gap, you have the lever. What makes the sound?
You drive the piezo disc underneath the lever with a high frequency signal again, 3 millihertz, just like the hoverboard whistle. This 3 millihertz vibration makes the gap oscillate rapidly, maybe between, say, 80 millimeters and 120 millimeter. Now remember how violently the attractive force changes with distance? $1
Right, it gets much stronger at 80 millimeters than at 120 millimeter.
Massively stronger. So the razor blade lever feels this huge pulse of attractive force hitting it 3 million times a second.
But we can't hear 3 millihertz. That's way too high.
Correct. But the razor blade lever itself can't possibly vibrate at 3 millihertz. It has its own mechanical inertia, its own much lower natural frequency, so it acts like a mechanical demodulator. It gets kicked hard by each 3 millihertz force pulse, but it recoils much more slowly. The overall effect is that the average force change causes the lever to vibrate or tap at an audible frequency.
So the lever clicking is the sound of the stress from the rapidly changing vacuum force.
You got it. The source says you hear audible clicks. Around 40 decibels, you're essentially hearing the lever react to the rhythm of the quantum vacuum pressure changing beneath it.
Translating quantum fluctuations into sound. And the really neat part, for the tech enthusiasts listening, if you then modulate that 3 millihertz carrier signal, say, switch it on and off at 1 kilohertz 1,000 times a second, the lever will click at 1 kilohertz. You can make it produce tones, you could play music from the vacuum.
In principle, yes. You could make the lever speak by encoding audio onto the 3 millihertz drive signal, and that sound pressure you're hearing. That's the exact same type of force that lifts the hoverboard, just scaled down maybe 10,000 times. Okay, we've seen static attraction, we've seen repulsion from vibration, we've controlled it with heat, we've even heard it. Let's look at the simplest lift demo now, the vacuum leaf. This sounds like the most basic version, maybe closest to a single hoverboard tile. It really is the conceptual core, yeah. The idea is incredibly simple. Take a tiny 1 centimeter square piece of foil, like from a chocolate bar wrapper, weighing only 0.3 milligrams, and make it float. Float about 100 micrometers above another piece of foil.
So foil floating on foil, what makes it lift? The actuator is just an old earbud speaker coil.
Yeah, a tiny electromagnet coil, pulsed at 3 kilohertz. But the real trick here is the spacer and the medium. They use a sort of net made of paper fibers between the foils. This creates a gap, but it's not a pure vacuum. It's an air gap, ranging from 50 to 130 nanometers in places.
Air, so it's not a pure Casimir effect then.
Not purely vacuum Casimir, no. When the 3 kilohertz coil pulses, the air trapped in those tiny pockets between the paper fibers and the foil can't escape quickly enough. It gets compressed and acts like a tiny, very stiff pneumatic spring.
Ah, so the foil vibrates, compressing the trapped air.
And that trapped, compressed air spring interacts with the Casimir van der Waals forces present across that tiny gap. The combination, driven at the foil's mechanical resonance, around 3 kilohertz, produces a surprisingly strong upward force. The notes say 3.1 millinewtons.
Which is
Yeah.
100 times the weight of the foil itself. So it floats easily.
Floats instantly and visibly.
But hang on, if this relies on trapped air acting as a spring, doesn't that contradict the hoverboard concept? If you scaled this up, wouldn't you just be building a fancy hovercraft, fighting air pressure, not using vacuum energy? That seems like a problem.
That's a really sharp question, and the sources actually address it. You're right, the DIY vacuum leaf does rely on that trapped air spring. Why? Because the actuator, that simple 3 kilohertz earbud coil, is relatively slow and weak compared to the forces needed. The air spring acts as a mechanical amplifier in the demo. It makes the small force generated by the coil effective enough to lift the foil at that lower frequency. It lets you see the lift principle without needing sophisticated high-frequency drivers.
Okay, so the air is a necessary crutch for the low-tech demo.
Exactly. But the full-scale hoverboard, with its precision piezo actuators running at 3 megahertz, doesn't need the air spring. It relies on the material's own stiffness and the sheer speed of the modulation, millions of times per second, to generate the repulsive force directly from the vacuum differential.
And the proof for the DIY version. The proof is simple. Take the working vacuum leaf and just put sticky tape over the edges, blocking the air vents created by the paper net. Seal it up.
Seal it. The lift disappears instantly because you've stopped the air from acting as that dynamic spring. It proves the mechanism in this specific demo relies on the interaction between the Casimir gradient forces and the trapped air dynamics.
Got it. So the DIY version shows the force potential, even if the mechanism is slightly different from the high-tech version. The core ingredients are there.
2 mirrors, a nanometer scale gap, and megahertz range motion. That's the recipe.
Scale down the gap by maybe 1000x compared to the Leaf demo, print millions of these cells instead of one, and suddenly that chocolate wrapper isn't just floating, it's lifting you.
That's the lead. So let's just quickly synthesize this for everyone, especially you future tech watchers. We've seen these kitchen table demos prove the 2 crucial types of force derived from zero-point energy.
Casimir attraction. The static clamp, that $5 prop to 1/4 over core force. We saw it in the Casimir in a cup, holding 2.8 grams.
That's the hoverboard stability, the magnetic traction field the force used to stick to the wall. Solid footing.
Casimir repulsion. The modulated force. Time average repulsion achieved by vibrating the gap. We saw this in the zero lift demo, making the slide lighter and the thermal snap pushing up.
And that's the active lift for the hoverboard, the propulsion, the steering, what the pilot felt as that warm spark underfoot energy interacting with the vacuum.
And the ultimate desktop proof that this scales. There's a note on an enhancement to the zero lift demo. They added a simple 9-to-1 lever as a mechanical amplifier to measure the force. With this lever, a tiny 1 milligram effective weight change happening at the chip. The actual Casimir component losing weight results in a much bigger, easily visible 10.8 milligram jump on the connected scale.
So you can clearly see the effect amplified.
You can see it amplified. The core says the chip is visibly lighter while it vibrates.
Mhm.
That's the final piece of the puzzle, isn't it? If 1 square centimeter on your desk can measurably lose weight by engineering absence, then a square meter of the same tech, properly engineered, absolutely can lift a person. Hashtag tag outro.
Wow, what a journey today. We went from descriptions of silent flight, the scent of absence, seeing the sky rotate around you, all the way down to proving the core physics with snack wrappers, nail polish, and kitchen ovens. It really feels like the blueprints for the first steps of this vacuum resonator revolution are right there, accessible on the workbench.
It really does. And the consistent theme across all the source material, the pilot log, the DIY guides, is this idea of engineered absence. It's not about raw power generation in the conventional sense. That tiny click you can literally hear in the Casimir clip demo, the sound of maybe virtual photons being momentarily excluded or rearranged.
Yeah.
That's the same fundamental force, just scaled up enormously, that the pilot log describes lifting hundreds of kilograms.
Yeah.
It all comes down to incredibly precise, repeatable nanoscale engineering of empty space itself.
So if the power source is literally the fabric of space-time, the vacuum itself, then what are the real limits? This is the question for you listening, especially if you're tracking future tech. If the energy is omnipresent, what's actually stopping this tech beyond, okay, the admittedly huge challenge of mass producing reliable nanometer scale engineering that can withstand vibration, temperature changes, dirt, everything?
Right, assuming the engineering hurdles can be overcome.
What other constraints are there? Could this really change everything about transportation, about logistics? What happens when friction truly becomes optional?
A provocative thought to leave people with. If the universe provides the lift, what does the vehicle of the future even look like?
Something to definitely mull over. Explore QED, explore quantum vacuum energy if this has sparked your interest. Thank you for joining us for this deep dive into zero-point propulsion. We'll catch you on the next one.